Okay, so here's our problem. Take a moment, look at it, write it down. And essentially what we have here is we've got a function and we know that it is equal to its power series on the entire real line, right? So for any real number, f of x is equal to this power series here. And we're supposed to figure out what is b sub 8. Now, the way we're going to figure it out is by using this theorem from the reading. So this theorem says that if f has a power series representation at a, okay, so now one thing I'll point out here is that the notation, instead of using C for center, the textbook uses A for center, okay, and Cn for the coefficients. Okay, and the formula, so if we know that f has a power series representation at some point, then the coefficients are given by this formula right here. So C sub n is equal to the nth derivative at the center divided by n factorial. And this is what we kind of hinted at and did a few, we guessed this formula by recognizing the pattern. Okay, so in our case here, what we have is our center is 5. So b sub 8 should be equal to the nth derivative. Well, now what is n? N is going to be 8, right? Because remember, the formula for the b sub n, the nth coefficient, is the nth derivative of your function evaluated at the center divided by n factorial. So for us, n is equal to 8 because we are trying to find b sub 8. N is equal to 8. And our center is 5. Okay? So b sub 8 will be equal to the 8th derivative at 5 over 8 factorial. And that's our final answer. So now we don't know what the 8th derivative of f is at 5, but all we can say is that this 8th coefficient, right? So the 8th coefficient is going to be the 8th derivative of f at 5 divided by 8 factorial.